Chapter 10. Geometry. Degrees, angles. We can measure angles in degrees. There are 360 degrees in one full rotation, one complete circle around. Angles can also be measured in radian. Parts of an angle. The angle is the amount of turn between each arm. The corner point of an angle is called the vertex and the two straight sides are called arms. Degrees can also mean temperature, but here we are talking about angles. The degree symbol. We use a little circle following the number to mean degrees. For example, this means 90 degrees. A full circle is 360 degrees. Half a circle is 180 degrees called a straight angle. Quarter of a circle is 90 degrees called a right angle. Measuring degrees. We often measure degrees using a protractor. Types of angles. Acute angle. An angle that is less than 90 degrees. Right angle. An angle that is 90 degrees exactly. Obtuse angle. An angle that is greater than 90 degrees but less than 180 degrees. Straight angle. An angle that is exactly 180 degrees. Reflex angle. An angle that is greater than 180 degrees. Now your exercise is identify types of angle. How to construct angles. In this section, we will consider the construction. Constructing a 60 angle. We know that the angles in an equilateral triangle are all 60 degrees in size. This suggests that to construct a 60 degrees angle we need to construct an equilateral triangle as described below. Step 1. Draw the arm PQ. Step 2. Place the point of the compass at P and draw an arc that passes through Q. Step 3. Place the point of the compass at Q and draw an arc that passes through P. Let this arc cut the arc drawn in step 2 at R. Step 4. Join P to R. The angle QPR is 60 degrees as PQR is an equilateral triangle. Constructing a 30 degrees angle. So, to construct an angle of 30 degrees, first construct a 60 degrees angle, and then bisect. Often, we apply the following steps. Step 1. Draw the arm PQ. Step 2. Place the point of the compass at P and draw an arc that passes through Q. Step 3. Place the point of the compass at Q and draw an arc that cuts the arc drawn in Step 2 at R. Step 4. With the point of the compass still at Q, draw an arc near T as shown. Step 5. With the point of the compass at R, draw an arc to cut the arc drawn in Step 4 at T. Step 6. Join T to P. The angle QPT is 30 degrees. Constructing a 120 degrees angle. We know that 60 plus 120 equals 180. This means that 120 degrees is the supplement of 60 degrees. Therefore, to construct a 120 degrees angle, construct a 60 degrees angle and then extend one of its arms as shown below. Constructing a 90 degrees angle. We can construct a 90 degrees angle either by bisecting a straight angle or using the following steps. Step 1. Draw the arm PA. Step 2. Place the point of the compass at P and draw an arc that cuts the arm at Q. Step 3. Place the point of the compass at Q and draw an arc of radius PQ that cuts the arc drawn in Step 2 at R. Step 4. With the point of the compass at R, draw an arc of radius PQ to cut the arc drawn in Step 2 at S. Step 5. With the point of the compass still at R, draw another arc of radius PQ near T as shown. Step 6. With the point of the compass at S, draw an arc of radius PQ to cut the arc drawn in Step 5 at T. Step 7. Join T to P. The angle aft is 90 degrees. Complementary angle. Two angles are complementary when they add up to 90 degrees. A right angle. These two angles, 40 degrees and 50 degrees, are complementary angles because they add up to 90 degrees. Notice that together they make a right angle. Supplementary angle. Two angles are supplementary when they add up to 180 degrees. These two angles, 140 degrees and 40 degrees, are supplementary angles because they add up to 180 degrees. Notice that together they make a straight angle. Triangle. Given the length of one side of the triangle, construct an equilateral triangle. Steps. 1. Place your compass point on A and measure the distance to point B. Swing an arc of this size above or below the segment. 2. Without changing the span on the compass, place the compass point on B and swing the same arc, intersecting with the first arc. 3. Label the point of intersection as the third vertex of the equilateral triangle. proof of construction. Circle A is congruent to circle B, since they were each formed using the same radius length. Since AB and AC are lengths of radii of circle A, they are equal to one another. Similarly, AB and BC are radii of circle B and are equal to one another. Therefore, AB equals AC equals BC by substitution, or transitive property. Since congruent segments have equal lengths and ABC is equilateral, having three congruent sides,